Hi, folks. Hope you are all having a great day. Welcome to the 126th episode of YFTT, Tech Talk by Engineers for Engineers. And I am Suranjan Kumar, Director of Engineering at Yugabyte DB. Today we have with us Saurav Tiwary, an engineer in the database team. Saurav will discuss the new improvements we have made in one of our existing feature called change data capture. Over to you, Saurav. Please introduce yourself and show us what we have today.
Sure. Thanks for the introduction, Suranjan. So, hey, folks, I am Saurav. I've been working at Yugabyte for the past 2 years in the database team. And I'm really excited to be talking about this today's topic, which is Postgres compatible logical replication in YSQL. I'm excited because this is something that the team has worked on over the past year or so. And I'm getting the chance to present it on behalf of the team. So let's start. So let's start with what a logical replication really is. So it's equivalent to change data capture, and it's a process of identifying and capturing changes made to a data in a database, and then delivering those changes to downstream systems in near real time. So your downstream systems could be data warehouses, data lakes, source replicas, right? And it's primarily intended for a variety of use cases, but a few of them are like data replication, where you want to keep a replica ready. For analytics, where if your downstream system is an analytical store where you can run your analytical queries, and you don't want to run those queries directly on your OLTP database. So that's one of the few use cases of logical replication. And we'll use the terms logical replication and CDC, change data capture, interchangeably throughout the presentation. So let's talk about what CDC right now, the current offering, before we get to the new offering that we are discussing. So right now, changes are streamed via a CDC service, which is hosted on the tablet server. So each machine in your universe hosts a tablet server, and on that there is a service named CDC service. And if you're a consumer of CDC, you are supposed to deploy our custom DBSM connector, whose job is to pull the data from this CDC service and push the changes to Apache Kafka, from where the downstream systems can consume the changes from. One of the things to note is that because this DBSM connector has to pull from CDC service, it needs access to the T server, right, tablet server. So it needs access to the port number 91000. To create and manage your CDC stream, we have YB admin CLI commands to manage your CDC streams. Okay. So roughly, I want to highlight 2 pain points before we proceed. So one of the first pain point I already discussed, which is like the connector requires access to internal ports of T server and master. So if you deploy connector somewhere else, you need to open up these ports from that network so that it is able to talk via the gRPC protocol, via the RPC protocol. The second pain point is the experience itself, which is YB-admin CLI commands. The CLI itself requires either the user to have SSH access to the machines in the universe or access to the master ports. So either if you're running the CLI from your own laptop has to have access to the master ports, or you have to SSH into one of the machines of the universe and run the commands. So these are the 2 main points. So let's talk about logical replication, and then we'll see how we kind of solve those 2 pain points. So let's talk about the model. So I want to talk about 3 main pillars of this model, like the consumption model, the syntax, and the protocol itself. So on the consumption front, this new offering will use the existing 5433 port, which is also exposed for executing your normal YSQL queries. The only difference is that you have to establish a new connection called a replication connection, and we'll see how to do that in the demo. On the syntax front, you are going to use PG-like syntax now through YSQL for creating and managing CDC streams. You no longer have to use YB-admin. Apart from that, you will also get views to observe the state of these CDC streams. So all of them within the YSQL familiar syntax. And lastly, protocol side. So on the protocol, the changes will be streamed via the same wire protocol that is used in Postgres. And what this allows us to do is that any client that understands this wire protocol will just work with this YSQL model. So before I move further, right, let's discuss like the 2 main concepts of logical replication. And these 2 both are inherited from Postgres. So one is replication slot and another is publication. So a replication slot represents a stream of changes that can be replayed to a client in the order that they were made on the origin server. So this ordering guarantee means that you'll never get any constraint violations of anything or anything if they didn't happen on the main server itself. Each slot stream represents a stream of changes from a single database. So this is also another key point to note. Replication slot is tied to a single database. It's a database within a database. And when you create a replication slot, you're created with an output plugin. So this is the more of a plugin based architecture, and this output plugin determines the format of the stream changes. For example, like Wall to JSON is a very popular output plugin within the PG ecosystem, and the output format is, as the name suggests, JSON. So your changes will be streamed via JSON. Similarly, PG output, this is a native PG output plugin that comes bundled within Postgres, and this streams data in the output format that Postgres understands. So let's move on to now publication. So if we only had a replication slot, there is no way to choose which tables you are interested in. So at the moment, a replication slot is tied to the whole database. So to allow that, Postgres introduces another object called publication, and this is just a fancy name for a list of tables. So publication is a metadata that specifies which tables to stream the data for. So it's just a list of tables. And the good thing about it is that you can alter it to add, remove tables on the fly later on as well. And both replication slots and publication together, they form a way to stream changes from a single database for a selected set of tables that you have specified in the publication. So let's talk about the syntax, and then we'll see all of it in action in the demo. So to create a replication slot, you can do, the command is create replication slot. You give the slot name, you give logical, because this is logical replication, and you give the plugin name. In this example, we have PG output. To drop the slot, it's pretty straightforward. Now to create a publication, you can say create publication, you give the publication name, and then you have a bunch of options. So one of the options is you say for all tables. And this means that you want the publication to include all the tables of the database. And this is a very handy default kind of case. But in most cases, you would probably want to specify exactly which tables you're interested in streaming the data for. And in those cases, you can just say for table, and you can list down in a comma separated manner the list of tables. As I said, one of the good things is that you can alter it later as well. So you can say alter publication, and you can remove a table from it. You can add a table from it. And finally, you can drop a publication once you don't need it. So once you're ready, once you're set up with this replication slot and publication, you can actually start the streaming. And the streaming happens through the start replication command. And you give the slot name, and then you give the publication name. So the slot name and publication name together, they allow the database, they allow us to determine which tables you are interested in, and we stream the changes from those tables. This logical and this 0/2 is the starting point. This is more like a integer that points to a specific position. This is something that the server itself returns. It's a client server protocol, and most cases you'll start just, if you're starting from the beginning, you'll say 0/2. In other cases, you'll just say whatever it was the last point that you received the data for. So without further ado, let me start with the demo. So this is a pre-recorded demo, and I'll just walk you through this. So what I have done here is I have a fresh Yugabyte instance running locally, and I've connected to the Yugabyte database via the Yugabyte user. So the first thing we'll do is we'll create a table, which we'll do that here. So it's an employees table. It has 4 columns: employee ID, name, email, and department ID. So once we're done with the creation of a table, this is the table in which we'll insert the data, and then we'll stream the changes to the client from. So the first step now is to create a publication. In this case, we're creating a publication named DemoPub, and we have configured it to include all the tables of the database. Right now, this is a fresh cluster, and this is the only table that exists in the table. So this will only include this table. You can view all the publications that exist in your database using this view called PG publication. And at the moment, it just shows this one publication, DemoPub. There's not a lot to look here. The owner is the OID of the user who created it. So now we have created a table and we have created a publication that includes that table. Now the last step to configure logical replication is to create the replication slot. Now a replication slot, as I said earlier, is created via a special connection called replication connection. And to do that, if you see the command difference, the difference is that we provide this replication equals to database parameter. And if you do that, it starts a special backend called the wall center backend, which is capable of executing these special instructions, the special commands for the creation of the slot. So in this case, we are executing this create replication slot. We've given it the name demo slot. We have given the name logical, and in this time we are using vol to JSON, and we're using JSON because it's much easier to present and show. So once this is done, the command returns successfully, and we get a replication slot ready for us. So now we are ready. So okay, yeah, before that, so now the PG replication slots view can be used to view all of the replication slots that exist in the system, similar to how PG publications can be used to view all the publications. So again, this just shows one replication slot, which we just created right now. It has a bunch of data, for example, the output plugin that you've used, the YB stream ID, and all the other details that you can use to view the state of your replication slot. So now that we are ready with the setup, right? We have created our table, we have created a publication, we have created a replication slot. Now we are ready to start a client that will consume the changes from this table. And in this case, we are using the client we are using is called PG receiver logical. We have configured this client to use this same slot, this demo slot that we just created here. And we have connected to the same Yugabyte user. Okay. And this, by the way, this PG receive logical is a client that comes bundled within Postgres itself. So it's a PG client that just works with the Yugabyte instance. So now we are ready to actually do some DMLs. So what we've done is I've done two inserts here in the employees table with a commit, and we can see that the data comes to the client in the JSON format because remember, we use the vol to JSON format. So next up, we'll do an update operation as well, just to showcase different capabilities of this logical replication. So once you do an update operation, it also comes successfully to the client, as highlighted in this with the correct values of all the columns. Next up, we'll do actually before that. So right now, what you see here at the very last line is the client confirming. So the client has to periodically confirm to the server that they have received it till certain point. And this is useful for checkpointing, right? So that once the server has been told, the client has acknowledged that it has received till certain point, the server can actually release resources and we can release resources. So here the client has actually confirmed that it has received every record till this update record. Okay, and this was just a mistake. So now once we get to the delete operation, we can see that the delete has been successfully replicated to the client. But what you'll also see is that on the very last line, I have purposefully stopped the client from sending the acknowledgement for this delete. So the client was not able to send the acknowledgement for this delete operation. So what will happen now is if I restart the client here, the client will receive the delete operation again. And this happened because the server was not told that the client has received the delete operation. And in this way, this is what leads to the at least one semantics of the changes. Like there's no data loss, but there is at least one semantics where like you can receive it more than once if the client fails to acknowledge to the server that it has received certain changes. So this was my first part of the demo on basics. Now we'll move on to the next thing where we'll talk about schema evolution. Okay. Yes.
So the PG receive logical being a standard client.
Yes.
But on the Yugabyte side, does it require any configuration change to have wall to JSON or this logical replication enabled? Or
No. It's
okay.
just nothing. It just works on the fly with us. Like that's what we
So
mean by compatible. It just works.
okay, it is pre-bundled with all the plugins.
Yes.
Okay.
So so what you have done here is that this is an alter table command where I have added this extra column to this employees table. Remember, this client is fetching the information from this employees table. So now what we have done is we've added a new column here on this table, and then we do another insert now, including this column. Okay. And what we can see that the server has transparently handled this, and it sends this new table as well without no changes necessary on the client side, no restarts or anything. It just works like that. Okay. So one final thing that I want to talk about in this PG receive logical demo is the concept of a dynamic table. So, so remember that when we created this publication, we created it with a for all tables criteria. And that means that it includes all the tables of the database, including future ones. So in this example, now what I've done is that I've created a new table called projects added to the same Yugabyte database. It includes these three columns. And now if we insert, yeah, so this projects table, right? So now we'll insert this another row into this projects table. And what we can see on the right-hand side now is that the new data from this projects table has also been received by the client, again, without any change needed on the client side. Okay, so that wraps up my demo on PG receive logical. The next thing I want to talk about is, so this was like a very basic client that works, that is because it comes pre-bundled with Postgres, and it is good for testing purposes and basic utility. But like now let's look at a scenario where we are deploying a complete end-to-end solution. So what I'm going to deploy now is a Yugabyte connector and a Postgres database, which acts as a sink. So the database on the left, the screen on the left will contain the Yugabyte database, and on the right-hand side, we'll deploy the Postgres database and obviously the connectors. And we'll see that the changes will flow from the Yugabyte database to the Postgres database. So the first step here was so I've written some shell scripts here just to deploy the connector. So the connector has been deployed. And as part of this connector deployment, what it does is that it creates a publication for itself. So there is you don't have to go and create the publication yourself. This is something that the Debezium connector does on its own internally. So here the publication was created. And we'll see that it has also created the slot for itself. So both the steps of creating the replication slot and the publication is handled within the connector itself.
So I see that in the view, right, the plugin was PG output. So the connector uses PG output plugin?
Yes, the connector can be configured to use various plugins. So if you see on here on the right-hand side, the plugin name is PG output.
Okay.
So it was configured to use PG output. But I think it supports multiple different plugins. But because here we want to keep Postgres as the sink database, we are using the PG output plugin, so that because the Postgres will understand the PG output format. Okay, so finally we'll deploy the sink, which is basically the sink connector as well as the Postgres database. So now what I'm doing is I'm logging into the Postgres database on the right-hand side. And first we'll see the state of these two tables that existed on the Yugabyte database. So firstly, I looked at the employees table, and we can see that the two records that were present on the Yugabyte side have already have already been replicated on the Postgres side. And these two records are called what is like snapshot. So these are the records which existed on the left on the source database before the slots were created. So those were replicated on the Postgres instance as well, which is Alice Johnson and Jane Smith. We'll look at the other database as well, other table as well, sorry, which is projects table. And this had just one row which we just inserted on the left-hand side, right? So this project A has also been replicated to the Postgres database. Next up, let me do an insert into the employees table on the Yugabyte front. And if we query the employees table again, we can see that this new record named Michael Johnson has also been successfully streamed as part of the to the Postgres database. And these records are called streaming records because they are created after the creation of the replication slot and once the client has started consuming the changes from. Right. Okay, so that's all I wanted to demo for this purpose. Let me move to the next slide. Right. So let's talk about the advantages from this new offering, right? Because this is something that we have that I touched upon earlier, which is that the YB-admin CLI commands, they require the user to have SSH access to one of those machines or either access to the master ports. So with this upcoming offering, you no longer need that because with PG parity, your YSQL queries and views will just run via the existing 5433 port, which is already expected to be exposed for running your queries and which is already secured via all of the security principles, right? So you don't no longer need to expose those ports. So that's a bit of a security advantage. Another advantage is the consumption itself, like, and also before that, like the YSQL queries and views give you a familiar. The expectation is that that is already familiar. The database administrators and the users are already familiar with these queries and views, so it brings a bit of familiarity to the work. Consumption side, the connector used to require access to internal ports, master and T server. That is no longer the case. Again, the same thing. You can use 5433 port. And lastly, I want to talk about the applications. So in the current CDC model, only YB connector, the YB heavily modified Yugabyte connector, could be used as a source application for the change data capture. Now, with the upcoming offering, because of all the advantages of honoring the PG wire protocol, any Postgres client available in the PG ecosystem can just work with this model with next to no changes. That also opens up, now we are no longer dependent on Kafka. You can still use Kafka, but it's no longer a requirement. And now the client can be coded in any programming language. The only thing is it should understand the PG wire protocol. Yeah, so these are just a bunch of references I've linked on each of the syntax. Yeah, that's all I have. Thank you.
Is this already available in Yugabyte DB latest release?
Yes, it is. I think the version would be 2024.1.1. Correct me if I'm wrong, Sanjay.
Yeah.
Yeah, so it's already available. Yes. So there was a.
Yeah, just checking if there are any questions from anyone.
Yeah.
We are good.
I can see one question, which is like, can any user create a replication slot and publication? So to create that, there is a special role in Postgres as well and then in YSQL, which is a replication role. So you need to have the replication role. So you can either give your user that replication role, or a super admin can obviously create a replication slot and publication. So they always bypass those security limitations.
And one of the questions was that the order that we, for example, there are transactions that spans across multiple tables, right? What are the options for the user? Do they get the changes in the transactional order, just like Postgres?
Yes. So any transaction, the ordering is determined on the transaction's commit time. So and at a time, so whichever transaction was committed first, it doesn't matter like the inner DMLs when they were executed, it's like the transactions commit. So whichever transaction committed first, you will get it first. Same as Postgres.
Yeah. All right. So, all right, folks. Thanks, Saurav. Thanks for walking us through the logical replication support in Yugabyte DB, and I hope users will try. And if there are any questions, please shoot us questions on the Slack, or you can give this feature a try on this Yugabyte DB instance. Thanks a lot.